Right. Cool. Good afternoon. How are we doing? Yay. All having fun? Yay. Cool. So we've got a bit of fun to round out the middle of the afternoon. And I want to start with a quick question for everybody. Who here has a cloud-connected device? Fitness tracker, smart home thermostat, Roomba, vacuum cleaner thing. Yep, all of us. We all have these kind of devices. Now, by a cloud-connected device, what I mean is a device that maybe you wear it, maybe it's in your home, it has some sensors on there, it gathers data, it ships that data up to the cloud, and then you have a client app to then view that data. And then maybe you have some configuration that you configure on your client, on your mobile app website, and that configuration gets pushed up to the cloud and back down to the device. Now, these things are becoming ubiquitous. Pretty much everything from washing machines to toothbrushes, everything these days is becoming cloud connected. So I want you to imagine your boss has come to you and said, we need to build our new cloud connected MacGuffin. You need to build your cloud connected thing. So where do you start with the prototype? Obviously, the first thing you want to do is build a prototype. Where do you start with the prototype? You need to think about hardware. These are devices with sensors, with capabilities. You need to think about hardware. You need to think about software. The hardware you've got will be running some kind of software. You need to think about that. You need to think about the software you have in the cloud. You need to think about the software you have on your client. So how do we get started? How do we do this? So I want to talk about this from the perspective of a cloud-connected fan. My lovely device here, held in place with some unicorn duct tape. So, seeing as it's lovely weather out there, I thought it'd be really cool to build a climate control system on a smaller scale. The purpose of this device is it monitors the temperature. If the temperature exceeds a certain point, the fan comes on. When the temperature goes back down, the fan goes off. And I want to get this data up in the cloud so I can access it from a client app. And I want to better configure the temperature at which my fan goes on and off from my client app. So let's kind of just talk through this. The first question that comes up is, what do I need? Well, I need hardware, obviously. I need software on my hardware. I need software in the cloud. I need software on my client. So let's start by thinking about the hardware. We need to have some hardware here. Now, when you're building a prototype, you don't want to start creating custom hardware. It is very expensive to start printing circuit boards, getting custom-built silicon. You don't want to be doing that. Ideally, you want to start with some kind of prototyping board. Ideally, you want to start with something that you can code easily, that works with your existing coding tools, languages you know, something that's got sensors already built in you can take advantage of, and maybe expansion, an ability to sort of do more stuff with it. Now, the particular board that I happen to like is the MXChip, or the Azure IoT Devkit. I love this board. Now, I actually got into IoT about a year ago, simply thanks to one of these boards. A friend of mine, Suze, she gave me one. I started playing with it. I got hooked. These are awesome. These are Arduino-compatible boards. They're pretty cheap. They're about 40 bucks or so for one of these. They have a whole load of stuff built in. So they've got microphone, headphone socket, infrared, Wi-Fi, Bluetooth. They've got temperature sensor, humidity sensor, accelerometer, magnetometer, and gyroscope to pick up all the kind of movement that you want to do with it. They've got buttons. They've got an OLED screen. They've got LEDs. Do we love LEDs? Yeah? When we're playing with IoT, we want the LED to light up. That's all we care about. This has got 2 LEDs. How awesome is this board? 2 LEDs, one of which is multicolor. So it's got all that, and it's got this lovely little finger connector at the bottom. Now, has anyone here heard of the BBC Microbit? Little tiny cheap computer invented in the UK where I'm from. Fantastic board. Kids play with it. We've got a whole load in our student zone that kids have been playing with. They have the same connector. The idea of this connector is you can clip on everything from crocodile clips, or you can plug this into an expansion board, and you've got pins you can control. So you can send signals out to do things. So in my case, I'm going to use the temperature sensor that's built into this board to read the temperature, and then if my temperature is above a certain threshold, I'm going to light my LED, because we love lighting LEDs, and then I'm going to send a signal to a relay. I'm going to send a data signal from a pin to a relay, flick the relay on, the fan comes on. When the temperature drops, turn off the signal to the pin, relay goes off, fan goes off. That is my hardware. Not too difficult for me to put together. I put it together in like an hour or so. Now, that's the hardware, but I need some software running on my hardware. And what's cool about the MXChip is it's Arduino compatible, so I write Arduino code in C, I write my setup and my loop that anyone who's done Arduino will be familiar with, but I can do it all in Visual Studio Code. There is an extension built into VS Code designed for doing IoT, and it's designed to work with this MXChip. I can not only write my code, deploy my code, but I can even debug my code. The MXChip has got the right debugging hardware. I can stick breakpoints on my code and step through it. So instead of me talking about it, should we see it? See the code? Yes. So flip over to Visual Studio Code. When you first launch Visual Studio Code with this plugged in, you install an extension called the Azure IoT Device Workbench. Every time you plug it in, this workbench pops up, and it guides you through creating projects if you want to. Now, there's some particularly cool projects down here. I like this one here. I think this one's quite a cool project. This gym guy seems pretty awesome. I'm liking what's going on there. But there's also other cool projects. My friend Suze has built this one, which is phenomenally cool. You can upload an animated GIF, and it plays it on the screen on the MXChip. That is a lot of fun, that one. So I launch Visual Studio Code, plug my board in, spin up a project, I start coding. Now, who's done Arduino programming before? Yeah, a few hands. So with an Arduino program, you have your .ino file, your sketch, and you base everything around two functions, setup and loop. Now, in my loop function, this is where I want to get the temperature. The loop function, as the name suggests, is called on a loop. It's called loop, loop, loop. It's called again and again and again and again. Now, in this function, I want to get my temperature. So I've got my getSensorData method here. This initializes the HTS221 sensor, the humidity and temperature sensor. It spins this up, and it requests the temperature, which I get out here. I call getTemperature. It's a really nice API that comes with the MXChip for accessing the sensors. And then once I've got my temperature, zip down to my code down here, I check it against my threshold. If it's warmer than my threshold temperature, I set the color of my LED. It's an RGB LED. Send 255 to the red channel, nothing to green and blue. It goes red. And then I do a digital write. So that's how I send a signal on a pin out to my relay to turn my relay on. If I'm below the temperature, then I set the blue LED, and then I turn off the signal. I write a 0 to the signal, and that turns the fan off. So if I just zip over here, and I spin up QuickTime, and I launch a new movie recording. Right. Say hello to the camera. Say hello. Yay. Right. So if I dip it down here, I'm hoping this is going to focus. This camera can be a bit flaky when I focus. So here is my board. You'll see it's currently showing a temperature of 22.6. And my blue LED is lit, because we love LEDs. Now, I'm plugged into this BBC Microbit Inventors kit. And that gives me some pins, wires onto a breadboard. And then I am plugged to a relay down here. And then that's wired up to my fan here. So the moment my temperature is 22.3, I'm going to stick my thumb on here to warm it up. You'll see the temperature going up, 26. I'm hoping my thumb's warm enough, 27. It's obviously a bit chilly in here. Let's see if I can get warm a bit quicker. And then hopefully in a second, when it gets warm enough, I should have hugged a cup of coffee before doing this, shouldn't I? Come on, warm up. The aircon in here is obviously too good. Come on, you can do it. You can do 28.9, you can do it. One more. There we go. Yay. Fan comes on. Thank you very much. My LED goes red. And then when I take my hand off, as it cools down, LED goes blue, fan goes off. So that's my hardware. That's my device software. That's all working pretty sweet. Now, this is great just from the perspective of a climate control system, but this isn't a cloud-connected device. And I don't know if you know this, but we at Microsoft, we like the cloud. I don't know if you heard that concept. We love it. So how about we connect this to the cloud? And I can do this with a thing called Azure IoT Hub. I love IoT Hub. IoT Hub is a service to connect, monitor, and manage IoT devices at scale. I can do one device for a demo. I can do 100 devices. I can do 1 billion devices. This is useful for me playing right the way up to if you wanted to set IoT devices across this entire convention center. You can just take data and just plumb it into IoT Hub. At its kind of most basic feature, it takes data in. It uses the MQTT protocol, which is a very lightweight messaging protocol for IoT, and you can just pump your data in from all your devices. Obviously, it does a lot more. It's got security around devices. It's got the ability to push configuration down to devices, to manage the firmware on the device, a whole load of stuff. But first instance, I'm using this to take my data in. So I can send an MQTT packet from my MXChip up to our Azure IoT Hub. Now, once my data's in the hub, I need to do something with it. And I can do that using an Azure Functions binding. Who's used Azure Functions? Yay, lots of people, cool. Azure Functions is our serverless offering. It allows you to create event-driven code. You write a block of code, an event happens, the code is run, and we charge you a small amount of money per million times that we run it. So it's very cheap and a great way to run code. Oop, press the wrong button here. And what's cool about Azure Functions is it has a whole lot of what we call bindings. So it allows you to connect your function to events, to services, just through configuration. So I can define a function. Through configuration, I can say, listen to my IoT Hub. Through configuration, I can say, connect to my Cosmos DB database. And every time an event gets raised, every time an MQTT message comes to my MXChip, goes into IoT Hub, triggers my Azure function, and my code goes in Cosmos DB. I can do this in like 11 lines of code. It's really, really nice way of creating event-driven code. So I can use this, I can use Azure Functions to push the code, to push my data into Cosmos DB. Now, of course, once my data's in a database, I want to get this on my client. And again, I can do that with Azure Functions. I can create an Azure function that responds to an HTTP request. That gives me a REST API. I bind that to Cosmos DB database, and I literally do one line of code that says, return the thing, and I can get my data out. I've got a nice REST API to query the data that went in from my IoT device. So the last thing I need to think about is the temperature at which my fan comes on. How do I configure that threshold which the fan comes on and off? And that I can do with a thing called the Azure Device Twin. I love device twins. It's so cool. It is, at its most basic, a JSON document. It is just a JSON document. But when I update the JSON document in the cloud, it gets pushed to my device. If I update it on my device, it gets pushed up to the cloud. And this allows me to manage configuration. And what's cool about it as well is it works offline. So I update it in the cloud, my device is offline, nothing happens. As soon as my device comes online, it gets the data pushed down to it straight away. So I don't have to ensure my device is online when I do it. I can change the configuration, and then as soon as it connects, I get my data. That is really, really cool. So enough talking. Should we do more demos? Yeah, let's do it. Cool. So if we start with Azure IoT Hub. So I send data up over MQTT. With the MXChip, there's a whole lot of libraries built in to make this happen for me. So this is Devkit MQTT client. It just comes with the MXChip C library, and then when I get my sensor data, I call my send data function. My send data function does a little bit of horrible C code to format the date, plums it all into a JSON string, and we call send event instance. Just that one line of code, and that's it. Everything's going up into Azure IoT Hub. And if I flip over to my Azure IoT Hub here, if I refresh this, I should hopefully see some data. It's not playing very well today. There should be some data in here. There we go. See? So these are all my messages coming in. So from the Azure portal in IoT Hub, I can actually see a live overview of my data coming in. Now, what's really cool as well is if I wanted to, from inside Visual Studio, I can actually find my devices and actually show the messages. I can see the live stream of JSON inside Visual Studio Code. So I don't even have to go into IoT Hub. I can actually debug the JSON by watching it come through from inside VS Code. Now, this gets my data into Azure IoT Hub. I then need to do something with it with my Azure function. Cool. I've got my Azure function in here. Where's my code? Here it is. This is my IoT Hub trigger. I have defined this as so this thing here, this IoT Hub trigger attribute. It's a C# code. You can do Azure Functions in a whole raft of different languages. But this simply says, connect to IoT Hub and use this connection string. That's it. As soon as I drop that in, this code will be called every time data gets sent up to my IoT Hub. And that data gets passed into my function. I have my data. Bosh. Next thing I do, I create Cosmos DB. Cosmos DB, here's my database details. This is an out parameter, which means whatever data I put in here gets inserted in Cosmos DB for me automatically. Isn't that lovely? So all I have to do in my code is a bit of logging, because we like a bit of logging, get the data out, build up this object, bang, into Cosmos. Done. What have we got here? We have got 12 lines of code, 2 of which are log statements, some of it is white space. So I wouldn't say this is simple because you have to understand how the concepts work, but I don't need to write much code. A lot of the boilerplate, a lot of the hard stuff is done for me. So I can just focus on the business logic that I care about, not boring old plumbing. So I do this, I get my message in Cosmos DB. So what I can do is I can flip to my Cosmos DB tab, because in Visual Studio Code there's a Cosmos DB extension. I go in here, I've got my Cosmos DB extension. I can open my collection, open my document. Here we go down here. There's my subscription, my Cosmos DB database collection document. I have a look here, and it's 24.9 it says here. Yep, looks about right. There's my document. Awesome, so I can debug what I'm doing in Cosmos from inside Visual Studio Code. Now, this is great, you know, but I want to actually get this in some kind of client app. More Azure Functions. Azure Functions for everybody. So I've got an HTTP trigger. This is a REST interface. It's at a root of temperature/device name, and what happens is, due to my lovely little syntax here, whatever I go to my REST endpoint /temperature/whatever, it takes the whatever, it plumps it into my Cosmos DB query, pulls back my data, and I just return it. All the plumbing's done for me, so I can just get my data back. And that gives me this really nice REST API. In fact, if I flip over to Postman here, I can just call it here. I call my REST API, 23.3 is the current temperature that's showing. Excellent. I've now got an ability to get the temperature from here, up in the cloud, into my client. Now, I want to configure the point at which my fan comes on. I want to set that. And I want to do that with Azure Device Twins. So one more Azure function, because we love Azure Functions. Another HTTP trigger. In here, I patch the JSON of my document. So the device twin is a JSON document. I request my device twin for my device. I say, give me the JSON document, and then I patch it. So there's a whole nice API. I don't have to build an entire new JSON document each time. I can simply say, I want to patch a desired property called temperature threshold. That just adds one row to my JSON document, or updates the row if it already exists, and then I update the twin. Once I call this, the twin is updated in the IoT hub, gets pushed down to my MXChip. If my MXChip is offline, next time it connects, it pulls this down. That sets my temperature configuration. And again, I can do that from inside Postman. I can make a post request. I can set my threshold to be 20. In a second, that'll be pushed down and my fan comes on. There we go. Nice. And then I can round that back up again. I can say I want my threshold to be, let me think, 29. Set the threshold, it gets pushed down, my fan goes off. And the way this is handled on my MXChip, when I call my setup, when my device first starts up, connects to Wi-Fi, I set my device twin callback. This is the function that's called every time the device twin is synced down to the device. I do a little bit of JSON parsing. It's not very nice handling JSON in C, so sorry about that. That's not so nice. But I pull out my temperature threshold here, and that way, next time my loop function calls, it's got the new temperature threshold. Awesome. So what have we got so far? We have got some hardware. We've got a temperature sensor. We're taking that temperature, sending it up to the cloud. We're using the temperature to control a fan. We've got an API to get the temperature. We've got an API to configure the point where the fan goes on. But obviously, our customers don't use Postman. Wouldn't it be really annoying you buy this wonderful smart home control system and we give you the REST API and so you have to connect over Postman? That would be annoying. But of course, it's just a REST API. I can call it from anything. Who does Xamarin development? Who was here earlier watching James Montemagno show off all the cool stuff? Yeah? Cool. Well, let's do some of that. You know what? I've got a Xamarin app here, and I've got my URL of my Azure Functions. It's just HTTP requests. So I can take a usual HTTP client. I can make a GET request to get the temperature. I can make a SET request to update the threshold. And if I zip over here to my app running, my temperature is 23.4. Let me drop the threshold down to 21. I click that. It makes a request. My fan comes on. Awesome. I ramp it up, I do that, it gets pushed down, my fan goes off. All down from my mobile app, and of course, as I adjust the temperature here, we should see in a few seconds, the mobile app should update. There we go, it updates to show my temperature. Awesome. So what have we done? We've got hardware. One board to rule them all. One board with all my sensors, a lovely breakout system, can connect up to the cloud. I've got a breakout from there to a relay to a fan. I get my temperature, ship it up to Azure IoT Hub. Azure Function gets fired, saves it to Cosmos DB. Set of Azure Functions to control everything, one to get the temperature, one to control the temperature threshold. That goes put into a device twin, automatically pushed down to my board. Everything works. I have my prototype. My boss is happy. I go home with a nice big fat bonus. Cool. So thank you very much for your time. Hope this was fun. I'm Jim Bennett, I'm a cloud advocate at Microsoft. Take a photo of this. This is the important part. Take this photo. That's me on Twitter. Follow me. I tweet IoT stuff, mobile stuff, and just general rubbish. But if you go to akka.ms/IoT fan, that is a GitHub link with everything you need to recreate this. There's links to buy the board, there's how you set it all up, and there's links to all the relevant documentation that you need to learn about IoT Hub, device twins, and functions, and there's the code there. So thank you very much, and enjoy the rest of Microsoft Build.